Today we're going to explore how Magryn and Associates and Larcombe General Builders designed and constructed a world-class ecotourism experience in one of Australia's most remote and harsh environments. Good morning and welcome to our webinar case study on Admirals Arch. I'm Kelly Stewart, Marketing Manager at Wagners CFT, and I'm here with Will Souter and Ouban from Magryn and Associates, as well as Jake Nolan from Larcombe General Builders. Will is the Technical Director at Magryn and Associates and a chartered professional engineer, bringing more than a decade of consulting experience in structural engineering, particularly in the coastal and marine space. Meanwhile, Ahmad is a civil and structural engineer with Magryn and Associates and excels in designing and managing a variety of structural projects. He's also proficient in using advanced engineering software for structural analysis and has extensive experience in forensic and remedial engineering. Jake is the construction manager at Larcombe and has led rebuilding efforts on Kangaroo Island post devastating fires in 2020, which were the most extensive fires ever recorded on the island. Jake has 14 years' experience as a carpenter and specialises in tackling projects with unique designs and complex engineering challenges, especially within an environmental or sustainability focus. We're also joined by Wagner's Business Development Manager for South Australia, Robbie Wesley, and Robbie seems to be having some technical difficulties at the moment, so we'll just persist and work through that. But welcome Will, Ahmed, Jake and Robbie. Before we get started, just a few webinar protocols. We are recording today's event and we'll make the recording public via the Wagners CFT YouTube channel. You can ask a question anytime during the webinar via the chat bubble at the top of the screen. However, we will hold your questions over to the end of the webinar for the Q&A session. And for anyone having difficulty with the chat facility, feel free to text your questions to me on my mobile. I have just put my mobile phone number in the chat now. So if you can't use that chat facility, feel free to text through your questions. All right, well, let's jump in. Robbie was going to set the scene for us and tell us a little bit about Kangaroo Island, but I think we're having issues with his presentation. So just one moment while I grab that up. All right. Kangaroo Island is the jewel in South Australia's tourism crown. It's located off the southeastern tip of South Australia. Kangaroo Island is just under 4,500 square kilometres with a population of approximately 4,700 people. It is the second largest island in Australia. Over 200,000 people visit Kangaroo Island every year, with approximately 120,000 of those visiting Admirals Arch and Remarkables Rock. Over a third of the island is protected nature reserves with pristine coastlines. There's wineries there, oyster farming, beautiful wildlife parks, many areas of cultural significance and numerous native flora and fauna attractions. Admirals Arch itself is a natural rock arch created by amazing forces of nature, and tourists access Admirals Arch around the cliff face by stairs, which leads down to a viewing platform where wild fur seals play amongst the rocks, and pups can often be seen swimming in the rock pools. It's truly an incredible view and an amazing opportunity for tourists on an international scale to watch fur seal in the wild, which is what makes Admirals Arch so popular with tourists. So what were the problems with the existing structure for the asset owner, which is South Australia's Department for Environment and Water? The existing timber structure had reached the end of its serviceable life. The timber was decaying in the harsh coastal environment and was becoming a safety issue for the asset owner, as well as a drain on resources with regular costly maintenance required to keep it open to tourists. Due to the remoteness of the site, it was a logistical nightmare to organise regular repairs. And given the popularity of Admirals Arch, it was also extremely difficult to shut down the structure for repairs, especially during peak tourist periods. But with rising maintenance costs, increasing safety concerns, and the potential impact to tourism, the asset owner made the decision to replace the existing structure. So what were the needs for the new structure? The Department of Environment and Water needed the job to be done quickly, preferably during tourism off-season or in a time that was not going to impact tourism to the site. They wanted to limit any impact to the environment during demolition of the old structure and installation of the new structure, owing to the importance of the area to the fur seal and due to it also being in a national park. Plus, they also wanted to ensure that the new structure was safe environmentally, so wouldn't leach horrible chemicals into the sensitive environment or shed microplastics into the ocean. They wanted a structure that was going to be low maintenance and have a long service life. So now that we've set the scene, I'm going to pass you over to Will Souter from Magryn to tell you about the design and engineering of new Admirals Arch stairs, boardwalk and viewing platform. Over to you, Will.
Thank you, Kelly. So I will just share my screen. Okay, so good morning, everyone. As Kelly mentioned, I'm Technical Director of Magryn and Associates, and this is Ahman, one of our design engineers. So we'll be sharing some insights and challenges we encountered from an engineering design point of view. So I'd just like to begin by sharing a bit about who we are and the work that we do. So we're a medium-sized engineering consultancy specialising in civil and structural engineering with a strong focus on coastal and maritime engineering. So we've got a particular passion for working on challenging projects in unique environments that deliver impactful results. So at Magryn, our vision is to help shape more resilient communities and infrastructure for the future by delivering engineering solutions that are future-proof, ensuring safety and sustainability are embedded in the designs. Our relationship with Wagners has grown over recent years, and we're proud to be one of their trusted design partners due to our expertise in fibre reinforced polymer, or FRP. Our experience designing with FRP has been tested on a variety of projects such as jetties, mooring facilities, boardwalks, beach access stairs and ramps. The Admirals Arch boardwalk is a great example of the type of project we strive to be involved with due to its unique location and challenges. So we're engaged by Wagners to undertake an independent engineering review and to certify their original design. So this is a 3D model that Wagners had developed, and we were also responsible for ensuring the as-built structure was installed as specified and all required design performance criteria and the intent was met. Just would like to start by summarising a bit of the background geotechnical investigation work that was done by FMG prior to construction. So the site geology consists of exposed limestone rock with a low to medium strength and contains widespread cavities, including large areas of undermining. While much of the weathering of the weak material had already occurred over many years, the limestone will continue to weather over time and over the long term. And at the low levels, the geology was a harder bedrock, as you can see in the photo here. So as a result of that, the footing locations had to be carefully chosen and adapted on site to avoid the weak or unstable areas. As you can see on this slide in the photo, an example of where some localised collapse had occurred. And as a result, careful design consideration and construction strategies had to be in place to mitigate the risks associated with ongoing weathering and to ensure stability of the structure over its lifespan. So some potential further geotech investigation was identified, such as detailed face mapping of the rock or core sampling to undertake testing. However, it was noted that this would be not very cost effective and would offer limited benefit to the new design. So as a result, it was determined that the expertise of the engineer, structural engineer and the contractor would be relied upon to identify the footing locations without the need for further extensive geotechnical investigations. So that leads into the safety and design aspects and considerations. When determining and finalising the locations of the posts, we undertook detailed case-by-case risk assessments. Potential for rock movement or weathering was evaluated, and where the risk was deemed too high, we made adjustments, whether that was relocating posts or introducing additional posts to spread the load more effectively and also add redundancy into the design. So this approach helped us ensure that the boardwalk remains safe and stable throughout its life cycle, even under these sorts of challenging conditions and changing conditions over time. And I will now hand over to Ahman to discuss further some specific engineering design criteria and challenges that we encountered.
Thanks for that, Will. I will now discuss the characteristics of FRP. FRP exhibits excellent resistance to corrosion and is incredibly strong relative to its weight, which makes it ideal for applications where weight reduction is critical. Despite being lightweight, FRP can exhibit tensile strengths comparable to or even exceeding steel in some other orientations. The site of Admirals Arch boardwalk was characterized by steep and uneven terrain, and accessibility was limited, so the lightweight nature of FRP made the logistics of construction a much smoother process. Now I will go into more detail about the different mechanical properties and behavior of FRP. So FRP is anisotropic. This means that its mechanical properties, such as strength and stiffness, vary depending on the direction of the applied load. FRP's fibers are aligned in specific orientations, typically along the load paths, which makes it very strong along the fiber direction, but weaker in other directions. This directional behavior requires careful consideration in design, ensuring that loads are aligned with the fiber orientation. This is in contrast to steel, which is isotropic, and its mechanical properties are uniform under all load directions. The anisotropic nature of FRP requires careful connection design. This is clearly shown in the table below, extracted from the Wagner's design guide, where the differences in the shear capacity in the transverse and longitudinal directions is noteworthy. Another point of contrast between FRP and steel is ductility. FRP exhibits limited ductile behavior, meaning if FRP members were to fail, the member will display little warning up until the failure of the member. Instead of FRP yielding under load, it tends to behave elastically up to a certain point and then fails suddenly. The lack of plastic deformation necessitates a conservative design with higher safety factors, which is accounted for in the Wagner's design guide. When overloaded, FRP may fail in a number of ways, including fiber rupture and crushing, which is characteristic of hollow FRP sections. Fiber rupture occurs when the applied tensile stress exceeds the strength of the fibers, leading to failure of the fibers and subsequent failure of the member. Crushing of an FRP member may occur under high concentrated/bearing loads, especially in hollow sections. This necessitates the use of anti-crush inserts to prevent crushing of FRP hollow sections subjected to high concentrated or high bearing loads. This occurs where FRP hollow sections have been bolted and the bolted connections are under high tension, resulting in deformation of the hollow section, thus requiring anti-crush inserts. The unique topography of Admirals Arch called for unique solutions to be implemented to provide adequate support to parts of the structure. An example of this is the use of FRP hollow members to support bearers directly onto rock, with anti-crush inserts to protect the hollow FRP profiles from crushing. Where feasible, the footings of the original structure were used to maximize efficiency. Despite not being in accordance with the original drawings, the moment capacity of piles embedded into rock likely met or exceeded the moment capacity of base plates and chemical anchors used on other parts of the structure. The challenging topography of Admirals Arch called for some adjustments during the construction phase to accommodate the irregular and steep terrain and provide additional support to the structure where the underlying rock was unsuitable for post supports. The differences in the layout of the actual and design structure are shown on the overlay of the as constructed survey onto the original design drawings. Another challenge that emerged during the construction phase of the project was providing adequate base plate support in the steep terrain. It was a specific requirement from the Department of Environment and Water, DEW, that breakage of rock be minimized to preserve the site's natural state. Hence, the breaking out of rock to provide a stable platform for base plates was not possible in most cases. Consequently, this led to some base plates being positioned on very steep sections of the cliff or rock, and the grout pad being built up to 500 millimeters in some instances, which made these grout pads non-compliant with the manufacturer's specifications and original Wagner's design drawings. This is shown here, where the height of the grout pad exceeded 100 millimeters, thus requiring a solution in collaboration with Larcombe Builders and DEW. We came up with the idea to reuse remaining Wagner's deck mesh, provide confinement to the grout pad, and to minimize the effect of erosion on the grout pads over time. Chemical anchors were fixed into the rock, and the deck mesh was tensioned to the exposed faces of the grout pad to prevent blowout of the grout pad under load. The grout pads were not designed to exceed 100 millimeters in thickness, so this solution provided a degree of reinforcement to the raised pads. This was a satisfactory outcome for all parties because materials did not have to be sourced from outside of Kangaroo Island, which may have been costly, and the solution was implemented within the time frame of the project. Thank you for listening, and I will pass it on to Jake from Larcombe Building to discuss the construction phase of the project.
Just sharing your presentation, Jake.
Yep.
All right, you should see that now. Away you go.
Beautiful. Thanks for the introduction. I'm now going to talk about the actual construction phase of the project and some of the challenges that Larcombe General Builders faced and overcome to successfully deliver the Admirals Arch boardwalk, stairs and viewing platform replacement. Let's dive straight in. So timing was the first major challenge that we encountered. As we've already heard, Admirals Arch is located on the far western extreme of Kangaroo Island. And so this area and this structure cops the full brunt of the weather from the Southern Ocean. The extreme weather was something that we needed to consider in the timing of this project. The area is also very remote, with the majority of the island's infrastructure on the other end. So there's no Bunnings around the corner, and everything needed to be meticulously planned and packed to maximise our time on site. With 60% of tourists to the island coming to see the Admirals Arch, it was imperative that upgrades to the structure didn't impact the tourist dollar or their experience to the area. Plus, with winter too dangerous for us to work on site, the decision was made to build during peak tourist season, which is January through to April, but to limit the impact on tourism through this sectional staggered build, and we'll talk about that detail shortly. Our next challenge was planning the logistics of deconstructing the old timber structure and building the new fibre reinforced polymer simultaneously. We worked with the Department for Environment and Water to come up with a strategy whereby we sectioned off an area of the old timber structure that could stay and continue to service the tourists while we constructed the new structure. This included a traffic management plan and directional signage, together with cordoned off areas to ensure the safety of public to access the agreed areas. We also employed specialised machinery to minimise the impact on both the public and the existing structure. This included a 1.2 tonne mini articulated loader, which we modified to include wider wheels, so the weight of the machine was dispersed over the existing boardwalk to access the site. This little machine carried all the materials from the top of the car park to the first material holding zone. It was also used to remove all of the old material that was palletised and taken off site and out of the national park for disposal. So in this image, it shows up the top there, the car park. That's where we set up a holding yard to store all the materials. It's quite a distance down to where the actual arch is, as you can see with that lower circle there. And we'll talk about where we set up a zip line soon. So here's some images of how we staggered the build. On the left, we've got a picture where the public had 100% access to. That was not to be compromised. So we enabled to have, so they could see the arch at all the time. In this photo, you can see us deconstructing some of the old structure and utilising that as work platforms, and also simultaneously building the new structure. So staging was also a challenge for us at Admirals Arch. The boardwalk and stairs, they go over the face of a cliff and then return back on itself to the first viewing platform. So, and this looks out to the Southern Ocean. So as you can imagine, it's very exposed. So the prospect of carrying down the equipment over this cliff was a big logistical challenge. And it just was not feasible to do this by hand. The Department of Environment and Water also outlined that helicopters were not an option due to an osprey nest located nearby Admirals Arch. The eastern osprey are an endangered species with an estimated of 50 breeding pairs left along the South Australian coastline. So protecting that nest and making sure it was not disturbed was paramount to do. So we set up a zip line from the first material holding area just down from the car park, and this enabled us to get materials down to the actual construction area. It was approximately 35 metres long, and it enabled us to, and this was right amongst the territory of a fur seal colony. Yeah, so it was amongst a fur seal colony. So in the early part of this project, it was breeding season. So we had to have spotters watching for the fur seals because the males can get very aggressive. And later in the project, the weather turned poor and the pups arrived. So we needed to be vigilant of the mothers that were protecting their young, and the seals looking to get out of the rough weather by sheltering up under the viewing platform itself. So here you can see a pair of the eastern ospreys, similar to the ones found along the South Australian coast and at Admirals Arch. So circled up there, you can see our zip line that we established. It's made up of some heavy duty steel to brace it back, and you can see the stainless cable that we used to carry the pulley system. And as you can see there, just how close the seals are and how we had to work around their natural habitat. So as we've heard before, the geology of the site presented further challenges. The rock connections or the footings were a mix of direct embedment into limestone. So when we removed the existing structure, we were left with a very, in some places, a good footing that we could then embed direct into the limestone. This was particularly difficult in other areas because of the uneven and sharp drop-offs of the rocks. Additionally, as you've heard before, the excessive confinement of the grout that was required for the footing was a big challenge that we had to overcome. With these grout pads and stainless steel studs, we delivered the outcome to satisfy the engineers. So this was, as we've discussed earlier, one of these situations where it could have become a massive hold up on the project. So together working with the engineer and the client, this was a very good outcome to keep this project timeline moving forward. So there were a number of benefits of working with Wagners FRP on this project. Because it's lightweight, we were able to utilise our 1.2 tonne loader and zip line to get the materials onto the site. We didn't require heavy, big machinery or tools to do the job, owing to its modular nature. We were able to employ the staggered sectional build approach. Plus, we were also able to prefabricate the balustrades and handrails in-house at our workshop in Stokes Bay. We then transported these to site for fixing in place. This reduced our team's time on site, especially towards the end of the project where the weather was declining and we were coming into winter. The flexibility of the bulk supply of materials enabled us to make small yet critical modifications that were necessary to meet the structural demands of the terrain. We had to make adjustments in 3 specific locations to ensure that the structure met its design requirements on site. Because FRP would not rot, rust or corrode, it is perfectly suited for this environment, where it cops the full brunt of the force of nature from the Southern Ocean. It is also totally exposed to the effects of sun, and Wagner's coating ensures that this structure has a long life despite its exposure to UV. It has a 100-year design life, so I don't think I'll be back anytime soon to replace this structure. And given that we're locals and part of the community of Kangaroo Island, we look forward to the tourists of the area and the locals alike enjoying this amazing natural wonder of Admirals Arch for decades to come. So as you can see here, this is an overhead view of the completed structure and just shows some of the complexities that we faced in delivering this project. And again, this is just another view looking back towards the arch itself, showing that the photos don't really do it justice, but it really is a beautiful part of the world. So thanks everyone for your time today. That's it for me. Back to you, Kelly.
Thanks for that. Just quickly while I bring up my screen, I'm just doing a bit of juggling here. I'm going to give the guys a quick chance just to have a breather. I see that we don't have any questions in our chat facility there yet. So if you do have questions for either Will or Ahmed or Jake, feel free to pop them into that chat facility just now. And we'll get on to the Q&A session of this webinar very shortly. Just to give the guys a chance to gather their thoughts, I'm going to very quickly share my screen and tell you a little bit about Wagner's new website. So we do have a new website. You'll find it at WagnersCFT.com.au. I'd encourage you to go and have a look at that new website. It's full of fantastic information that is hugely valuable and useful. I also just wanted to tell you a little bit about Wagner's new Trident marine piles. If you hadn't heard about our Trident marine piles yet, they're durable with a 50-year design life, inert, so they won't react chemically and rust, rot or corrode in salty water or UV light. They are resistant to marine borers and acid sulfate soils and termites. They're lightweight, modular by design, and can be prefabricated offsite and trucked or lifted into place. And because they're non-leaching, they're safe for marine environments and animals. If you'd like some more information about those Trident marine piles, you'll find that on that new website, which is at WagnersCFT.com.au. At this stage, I am going to introduce Wagners CFT's General Manager, Ryan Leeson, who is going to help facilitate this Q&A session. So I'm just making sure we've got Ryan there.
Here, Kelly, and ready to go.
Great. All right. Well, it does look like we've got a question in there, Ryan, so I'll let you fire away.
We'll start with Ravi's question here. How long was your construction time, Jake? And maybe if you can, from sort of initial award through to when you got to site, and then how long your time on site was, if you could just give us a bit of a run through on that.
Yeah, sure. So the award was July the previous year, so in winter. As we discussed, we've been doing projects for DEW, the same client, for the last 4 years. We started works in January through some negotiations. Obviously, that is the tourist time. And at this time was very critical to get the project done. So it was from January through to the end of May. And because the daylight hours were so long, we were really making the most of that and getting it done.
Very good. I appreciate that. Question from me with a bit of a geotech background. Ahmed or Will, I'm not sure who can handle this one. With the unknown spans and the ability to be having to adjust the spans depending on how your footings and where they ended up, how did you sort of factor that into your design? Did you intentionally design the spans less than capacity so you had that bit of flexibility to push out as required, or just was that sort of constructability considered as part of your design phase?
Yeah, so I believe that was part of the design with a bit of conservatism to allow that flexibility. So yeah, maximum spans were established for the profile sizes that we had so that we could move posts like marginally as needed. And is that right?
Yeah, and like also when I went and did the inspection on site, I noted any spans that were longer than the design drawings, and we retrospectively calculated those, and they were adequate as well. So yeah, we had more assurance.
Okay, and follow on from that, and a lead in here from Jonathan from FMG as well. How did you assess the existing footings to determine if they were suitable to use, or did you just rely on the fact that the structure would be lighter than the timber structure with which it was designed? And then how many of those footings were you able to keep, and how many needed new ones?
So these are probably the footings that the posts were straight into the rock. Would that be right?
Yeah.
That one?
So I discussed it with Jake on site, and he told me that Wagners gave him a minimum depth that he had to go to, where he wanted to embed the post into the existing holes. So there was a minimum depth requirement, but if he couldn't achieve that, then he would just use the specifications in the design drawings.
But those holes were lower down in the harder bedrock, I believe,
yes,
weren't they? So there was a lot less uncertainty, or yeah, it was quite competent bedrock.
Okay, and again, a lead on here from Tony from the Holdfast Bay. What survey did you use as part of the design? And I'm not sure if that was part of Jake or Magryn's scope, but what sort of survey did you use as part of it? And what tolerances were you designing to? Or was it more a concept that evolved as it was built?
I can probably answer that a little bit. So because it was replacing like for like, we didn't engage them ourselves, but we worked together with DEW and the surveyor. So we established an as-built for the old structure, because that was what the client wanted to deal with at the end of the day, was the same as that. So we established that was accurate, and then we also overlaid that with the Wagners products to enable us to see if this was going to meet that specification. And as we did, it was very close. So at the end of the job, we also did an as-built survey. So DEW ran it through and made sure that for the future of this project, that we know where we're all at and what's been built.
Very good. Follow-up one, obviously, with the proximity to the ocean there and the southern seas that can be quite rough. Were wave loads factored into this design? And if so, how were they sort of calculated to then be factored in?
Yeah, wait.
Do you want me to answer that?
Probably something for Will, but
yeah, it's well above the required design level for the 1 in 100 year water level, accounting for sea level rise. That was looked at earlier on in the design phase, or yeah, basically when we were first engaged to establish where the wave loads needed to be considered. But it's high enough up the cliff there where it's not going to be a issue.
Okay. And with your zipline, Jake, was that a proprietary product, something you purchased, or was it something that you guys fabricated yourselves? Obviously, it's quite fitting for national parks style structures that are built all over the country. And no doubt people online will be interested with, where limited construction footprint's obviously very important. I'm sure other people would like to know how they can do a similar thing. Can you maybe just elaborate a bit on how that all came about?
Yeah, sure. So it's something that we made in-house. It had some safety constraints that we established. It's something that my father-in-law, who's the director of the company, he previously used this at the Ethels Beach wreck. He did a boardwalk there over a cliff. So we used the same concept and added a few extra safety precautions in. It's very custom for the job, but not to say that it can be used in other places, that's for sure.
Okay, fantastic. Did anyone else have anything else? Did you, either of Will or Ahmed or Jake, have anything else you'd like to add that'd be interest for the group? If not, we might call question time over at that point.
You can see there's another question there about how the surfing engineers were able to prove the mini mesh reinforced footings. So
yeah,
that was sort of an interesting engineering aspect of the project. So we looked at the critical posts basically, and the critical forces that were coming down through that grout pad to calculate the forces or the stresses through the pad that are likely to blow it out, to then check that against the span tables for the mini mesh and space the anchors that are securing it down through the grout accordingly. And those stainless steel anchors went through the grout pad and into the rock, so we're basically tying it back into the rock behind. So you end up with it being supported into the rock quite well, and preventing that the grout from basically holding it all together and preventing movement and deterioration in the long term.
Apologies, I missed that question, Dennis, and well answered. That was very interesting. Ellie, over to you.
All right, thank you very much. Just going to quickly share my screen. I've just got a couple of things to wrap up here. Could I kindly ask anybody who's attended today's event, if you can complete our feedback form, it helps us shape our webinars in the future and bring you a better product month on month. So I've just popped the URL link to the feedback form in the chat at the moment, or you can use the QR code on the screen. I also wanted to let you know that the next webinar is on the 25th of September 2024, of course, next month. And we're going to discover why Wagners CFT use vinyl ester instead of polyester resin, why we pull wind, where the numbers in the design guide come from, and how these numbers tie into quality assurance testing to ensure compliance. Plus, we're also going to learn how pultruded FRP is classified by modulus. Our guest speakers for that webinar are going to be Wagners CFT Global Business Development Manager Michael Kemp and Senior Composites Engineering Consultant Rick Heselhurst. So that's going to be a great one. Hope you can make it. You can either use the QR code on the screen to register for that one today. I've popped the QR code into the chat facility if you'd like to register for that. Or you will get a follow-up email today with those registrations, and you can register via that email follow-up today as well. So that concludes our presentation on Admirals Arch. I'd like to thank Will, Ahmed and Jake for your presentations today and for your fantastic responses to our to the questions that were asked. I'm just going to bring up that fantastic video that we came in on to leave our webinar today, and we look forward to seeing everybody in September for the next webinar. So see you soon.